Hi, my name is Joshua Cook, and I'm a curriculum developer with Databricks. Today we're going to be talking about latent semantic analysis. There's a link to the notebook I'll be using in the video description if you would like to follow along. Before we begin, let's define some basic vocabulary. Natural language processing refers to a family of techniques that are used to derive meaning from text data. A document refers to some collection of words and represents the rows or instances of our dataset. A body is a collection of documents and represents the entire dataset. A dictionary is the set of all words that occur in at least one document in the dataset. A topic is a collection of words that co-occur. In this lesson, we're going to be talking about latent semantic analysis. So the word latent means hidden, and in this context refers to features that cannot be directly measured. What we're going to be measuring, or what has already been measured, are the words that are in our dataset. What we're interested in is latent features, hidden features, that represent something essential in the dataset. Latent semantic analysis is a natural language processing technique as well as an unsupervised learning technique. This as opposed to supervised learning. So in supervised learning, we would have a target or a label. With latent semantic analysis, we don't have this. We're looking at something that's latent or inherent to the data itself. The aim of latent semantic analysis is to create representations of the text data in terms of these topics or latent features. A side benefit of this is that we're going to be able to reduce the dimensionality of the original text-based dataset. As you can see in this diagram, latent semantic analysis consists of two steps. The first step is to generate a document term matrix, and the second step is to perform a singular value decomposition on that document term matrix. The basic idea of a document term matrix is that text documents can be represented as points in Euclidean space. You might know these as vectors. Here is an example of a document term matrix. As you can see, each row in this matrix represents one of our documents, in this case, one of 4 simple sentence fragments. And then each column represents a word from the dictionary, that is, a word that shows up in at least one of the 4 documents. If you look at the first row, the quick brown fox, you can see that the word brown has the value 1, the word fox has the value 1, the word quick has the value 1, and the word the has the value 1, and everywhere else is zeros. So here we see these 4 documents as vectors. As you can see, the quick brown fox is 10, 10, 10010. The second step in a latent semantic analysis is to do a singular value decomposition on the document term matrix. The singular value decomposition is similar to a principal component analysis if you're familiar with this statistical technique. It's going to reduce the dimensionality of the original dataset by encoding it using these latent features. With latent semantic analysis, these latent features represent topics in the original text data. In the next few videos, we're going to be looking at building a latent semantic analysis using the open source Python library Scikit-Learn. First, we'll look at a trivial implementation using these 4 sentence fragments that we just looked at.